Hello, this is Mr. Rasmussen with Algebra 2 and Lesson 116. In this lesson we look at some probability and then also something, perhaps a new word for you, permutation. It starts out the example, if we take three letters, A, B, and C, there are 6 different ways that we can arrange them if we only use each letter one time. And it mentions there that we call the different arrangements of the members of a set in a definite order. We call that a permutation of the set, of the members of a set. So, as we see here, if we have 3 different spots and we only use the letter one time, well, there's 3 options for the first spot, 2 options left because we've already used one of them for the second spot, and only 1 option left for the third spot. If you multiply those, 3 times 2 times 1, you get 6 permutations for that example. If we change it and make it so you can use the letter more than once, well then in that case we have 3 possibilities for the first spot, 3 for the second, and 3 for the third. Multiply that together, and you get 9 times 3, which is 27 permutations. So with that being said, let's look at example 1. It says, how many different ways can we use the numbers 3, 5, 7, and 8 if no repetition is permitted? Well, there's 4 of the numbers, therefore we're going to use each one time, and so 4 spots. And in the first one we have 4 possibilities. We're not using it again once we use it, so 3 possibilities, 2, and 1. Multiply that out and we get 24 ways or permutations that you can get. Okay, example number 2. How many 4-letter signs can be made? So that means we have 4 spots, okay? And then we can use the letters from the word equal, which there's 5 letters in there. So, and it also says repetition is permitted. So in the first spot we have 5 options to pick from, 5, 5, and 5, because we can keep using them. Multiply that out and we get 625. Example 3. Example 3, the multiple choice has 8 questions to it, so we have 8 spots to fill. 1, 2, 3, 4, 5, 6, 7, 8. All right, and then it says it's multiple choice, which means that we have 4 answers to use again and again and again. So there's 4 in each one of these boxes here. Basically 4 to the 8th power. That's 65,536. All right, because we can use them again and again. All right, example 4. How many 3-letter signs? So we got 3 spots to fill. Can be filled with the letters in the word numeral. Numeral has 7 letters, so you have 7 options there for the first one. However, can we reuse the letters? It's saying no for this one. Once we use one of the letters, then we can only use it once. So there's only 6 possible letters left for the second part, and then 5. Multiply that out and you get 10 permutations for that example. All right, example 5. Jimmy has 5 places to put items. So that means we have 5 different boxes to fill. She has 38 different items. So 38 goes in the first box. However, there are different items. That's why if they're in one spot, they can't be in a second spot. So it'll be 37, 36, 35, 34. Multiply that all out and we get 60,233,040 different permutations. Okay, so hopefully that's somewhat familiar, well, not familiar, but somewhat easy for you to grab there as far as a new concept. All right, let's move on here to probability. We got heads and tails on a fair coin. You have a 50% chance there. You put the number of possible outcomes on the bottom and the number ones that satisfy the requirement on the top. You can see it talks about a dice there as well. Let's say, what are the possibilities for you to get 5 in a dice? Well, there's only 1 5 on there, so it's a 1, and there's 6 sides of the dice, so it's a 1 out of 6. Or greater than 3, that's 3 sides, 4, 5, and 6. So there's 3 possibilities that satisfy 6 sides. That's 3 out of 6, 1/2. Okay, let's look at some examples here. Example 6, 2 dice are rolled. What is the probability of getting a 7? All right, so if you look at this, we've got to use the chart there. there's 36 possible options when you add the two numbers for the two dice that are rolled. 7 shows up 6 times as far as possibilities inside of the chart there on page 454. And so we have a 1 in 6 chance of getting a 7. How about if we want to get a number greater than 8? Well, once again, 36 possibilities. If we looked at greater than 8, we've got 4 9s, 3 10s, 2 11s, and 1 12. That's 10 possibilities. We got 10 out of 36 for that one. All right. If we look at our fair coin again, example point 7 says the coin is tossed up 3 times. What is the probability that it comes up heads every time? Well, the chances for the first toss is half, the second toss is half, and the third toss is half. However, to get them to do that sequentially, then we multiply those together, we get a 1 in 8 chance. All right, because they're connected. All right, example 8, the fair coin is tossed up 4 times, comes up heads each time. What is the probability that it'll come up heads on the next toss? Well, on the 5th toss, it's an independent event. It doesn't matter what happened before that, so it's simply a 1 out of 2 chance to get that. Okay, let's take a look at the practice problems. On practice problem A, we're back to our permutations. We have 3 chairs to fill. So 3 spots, there are 7 students. Obviously a student can't replicate themselves as a clone, so they can only be used one time. So 7, 6, then 5. And if we multiply those together, then we get 210 permutations possible for our students sitting in the 3 chairs. Okay, let's look at practice problem B. This involves Roger rolling a dice 2 times. He wants the first whether the probability for the first one to come up on a 7. Well, we looked at that in the example problems. That's a 6 out of 36, so a 1 in 6 chance that the first one would be 7. And then it's connected with the second roll. So the second one is a number greater than 9. So there's 36 possibilities, and there's 10 3 times, 11 2 times, and 12 once. So that gives us 6 possibilities, which also reduces to 1 6. So for those to happen together, we have a 1 in 36 chance that that will happen. Okay, please feel free to contact me if you have some questions about this lesson, and have a great day.